When a heavy load slips from a crane, it represents a specific failure to calculate operational variables. Unmeasured risk creates a blind spot that leads to the majority of preventable workplace incidents. To eliminate these blind spots, you need to know how to construct and complete a formal hazard identification and risk assessment document, or HIRA, from scratch. Documenting risk is a practical tool. It provides the specific operational boundaries needed to prevent severe injuries and major workplace incidents. We will use 3 different workplace supervisors to demonstrate the steps. First is Alvina, who manages a team handling chemical cleaning agents in a hospital. Second is Quentin, a foreman overseeing deep trench excavations on an active construction site. And third is Jan, who manages logistics and heavy goods unloading at a distribution warehouse. Despite these vastly different daily operations, the structured HIRA methodology applies strictly to all of them. This flowchart outlines the SCANDER process. It begins at the top with planning, moves down to identifying hazards, and then proceeds to analyzing the risks. Step 1 defines the specific process. On Quentin's site, we go to our blank HIRA table and log the task, digging a foundation trench. Step 2 identifies the hazard, the source of danger. We log unstable soil at trench edges. The hazard causes the risk, which is the actual consequence. We add trench collapse leading to crushing into our consequence column and classify it as a safety risk. On a complex job site, hundreds of variables interact simultaneously. Pinpointing the precise source and its exact consequence isolates the problem so you can address it. The formula is rigid. Identify the hazard, trace it to a specific consequence, and you have to find your risk. Step 3 requires us to calculate the raw risk. This is the worst-case scenario evaluation before any safety controls are considered. This is a standard 5x5 risk matrix. We use this grid to calculate our raw risk score by plotting the potential consequence on the vertical axis against the likelihood of the event on the horizontal axis. For Quentin's trench collapse, the consequence is a potential fatality. We highlight row 5, representing a catastrophic outcome. Next, we evaluate the likelihood of a collapse if workers use 0 structural supports. We highlight column D, meaning the event is likely to happen. Where the row and column intersect, we get our final mathematical raw risk score, 24. This transfers directly into our HIRA document as a high risk. A high raw risk score mandates an immediate halt. Work cannot commence until interventions are put in place to lower that number. Moving to step 4, we identify current controls. Jan's warehouse already has mitigations in place, like painted pedestrian walkways and machinery speed limits. When we log these existing measures, our initial high score drops to a medium residual risk. This new number reflects the actual risk environment with controls active. Step 5 introduces additional controls. If the residual risk remains too high, supervisors must implement further protections using a framework called the hierarchy of controls. This stepladder graphic prioritizes solutions. For Alvina's ward, we start with substitution, replacing a toxic cleaner. Next are engineering controls, like installing ventilation. Then administrative controls, like limiting exposure time. At the bottom rung is personal protective equipment, or PPE. PPE sits at the bottom because it cannot eliminate the hazard. A glove or face mask acts only as a fragile physical barrier. If the barrier breaks, the worker takes the full impact of the consequence. Rigorous risk management requires supervisors to exhaust the top tiers of the hierarchy before falling back on PPE. Here is our fully completed HIRA document. Quentin, Jan, and Alvina's very different environments have all been quantified using the exact same logic sequence. As you build your own documents, do not guess the likelihood of an event. Rely on actual incident history and site data to accurately plot your matrix. Make sure you never list a hazard without attaching a specific consequential risk to it. An open manhole is an observation. A broken leg is a measurable consequence. Following these steps turns an administrative chore into a solid mathematical argument for safety. For your next step, select one routine task in your own workplace. Run that task through the workflow. Identify the exact hazard, calculate the raw risk, document your controls, and establish your residual risk score. Next time, in episode 12, we will examine the procedures for when controls fail and an incident occurs on site. Methodical preparation during your risk assessment is the most reliable way to keep your team out of an incident report.